Hello, everyone. You are watching Smart Capital, the School of Financial Literacy.
Glad to be here.
So today we are doing a deep dive into this massive, almost invisible macroeconomic shift that's just happening right beneath our feet.
Yeah, totally invisible to most people.
Right. Because I mean, right now everyone is just fixated on the digital landscape. We're all watching the markets, trying to figure out like which software company is going to build the smartest chatbot or the fastest code writer.
Or the best image generator, exactly.
Right. But in chasing the software, we are completely missing the actual once in a generation shift. And it is happening entirely in the physical world.
Yes.
It is the staggering, just unprecedented energy demand that artificial intelligence is creating.
It really is the quiet giant in the room.
Hmm.
We get so easily distracted by the seamless magic of the software interface that we forget about the heavy industrial physical machinery required to, actually make that magic happen.
Yeah, the hardware.
Exactly. So today's mission is to break down these complex macro level shifts. We want to explore how a purely digital concept like AI is, fundamentally breaking and rebuilding our physical infrastructure
Mhm.
and, how that translates into real movement within the financial markets.
Exactly. But before we continue, I'm curious how many of you are already interested in financial education or investing? Let us know in the comments.
Yeah, we'd love to see where everyone is starting from
For sure.
because navigating a market shift of this scale really requires looking past the surface. Like, we need to understand the mechanics of the energy grid, the constraints of raw materials, and just the sheer volume of capital moving into heavy industry right now.
Definitely. And hey, if you enjoy clear and simple explanations of financial topics like this, give this video a like so we know you want more content like this.
Absolutely.
Okay, let's unpack this. We need to start with the hidden cost of AI, which is, at its core, a physical data and energy problem. So, to set the baseline, you kind of have to look at the last 2 decades. Because for the last 20 years or so, energy demand in the United States has been essentially flat.
Which is crazy to think about, right?
Yeah. Even as our population grew and, we added all these screens and iPads to our lives, our microchips and appliances just became vastly more energy efficient. So the total draw on the grid stayed remarkably
Right.
balanced.
Balanced out.
But suddenly, over the last couple of years, that balance has just been completely shattered.
It is absolutely spiked.
Hmm.
And, to understand the underlying mechanism of why that is, you have to look at the computational difference between traditional internet architecture and generative AI.
Okay, break that down for us.
So let's look at a standard internet search. You type a query, the search engine indexes an existing database, it retrieves a link, and then you click it.
Very simple.
Right. The energy required to execute that traditional search is roughly equivalent to leaving a standard LED light bulb on for about 10 seconds.
10 seconds. I mean, it's barely a blip on the radar.
Exactly. But a single query on a generative AI platform, that is an entirely different mechanical process.
Because it's actually thinking. Right.
Basically, yeah. The system isn't just retrieving a static pre-existing link. It's actively computing.
Hmm.
It's synthesizing vast amounts of data, running complex probabilistic models, and, generating a brand new response word by word in real time.
Wow.
And the computational horsepower required to do that means one single AI query uses the energy equivalent of leaving that same LED light bulb on for 2 full minutes.
2 minutes. Wait, so we are looking at a 12-fold increase in raw power consumption for just one single question.
Yes.
A 12-fold increase. That is insane. And I guess you have to multiply that by hundreds of millions of users who, aren't just asking one-off questions anymore.
Right. People using it all day.
Yeah, we are having these deep ongoing workflows with these tools. We are running them constantly to like compile code, analyze massive Excel spreadsheets, draft corporate reports. And the truly wild part, we are still in the earliest adoption phase. I read that roughly half of all major US companies haven't even integrated AI into their daily operations yet.
Which means this energy spike hasn't even hit its steepest curve yet. Um, every single time you interact with an AI model, that intense computation has to happen physically somewhere.
Right.
It gets routed to a massive data warehouse. And I mean, these aren't the server rooms of the early 2000s.
No, not at all.
A single modern hyperscale AI data center consumes enough electricity to power an entire small American city.
A whole city, just for one warehouse.
Yes. And the mega cap tech companies, Microsoft, Amazon, Google, Meta, they aren't just building one of these, they're constructing dozens of them simultaneously across the country.
Okay, I like to think of it this way. Imagine for years you've been riding this lightweight 10-speed bicycle to work every single day. The roads are built for bicycles, the traffic flows smoothly at bicycle speeds, everything just works. But suddenly, literally overnight, you and millions of other people trade in your bicycles for massive gas guzzling Hummers for your daily commute.
That's a great analogy.
But here's the catch. You look around and you realize the local gas station only has one pump.
Right.
The demand just went completely exponential, but the infrastructure to fuel it is entirely static.
What's fascinating here is the physical limitation of the legacy U.S. energy grid. Like, you really have to understand why it is fundamentally failing to adapt to this.
Yeah, why can't they just, upgrade it quickly?
Well, our public grid was largely designed and built decades ago for a widely dispersed population using predictable, relatively low-draw household appliances.
Makes sense.
It was never designed to route the equivalent of a small city's electrical load to a single localized warehouse sitting out in some rural county.
Right, because electricity isn't just magic, it's physics. When you try to pull that kind of massive amperage through the legacy system, you run into real physical barriers. It's like trying to force the water volume of an industrial fire hose through a standard residential garden hose.
Yeah.
The friction and the pressure are just way too high.
Precisely. It's literally a thermal limit issue. The industrial transformers, the regional substations, the actual copper transmission lines, they lack the physical capacity to move that much raw power that quickly.
Wow.
If you try to force it, the copper overheats, the transformers blow, and the grid just melts down. The underlying physics of our current public utility infrastructure actively rejects the demands of the AI era.
That is wild. Think about how many AI queries you run in a day. Did you ever stop to think about the physical fuel burning to generate those answers?
Most people don't.
Yeah, it's a stark realization that your sleek, frictionless digital assistant is basically tethered to a roaring industrial furnace somewhere.
It perfectly illustrates how digital innovation inevitably hits a physical wall.
Hmm.
And, to truly understand where the capital is flowing today to fix this, we need to look back.
Look back away.
We need to look at the last time the United States faced a massive, sudden, unexpected need for new power infrastructure.
Okay, yeah, because this isn't the first time we've had an energy bottleneck driven by a huge societal shift.
No, not at all.
Let's do a quick history lesson here. We have to rewind to the period right after World War II, roughly 1945 to 1965.
Right, the post-war boom.
Exactly.
Yeah.
Millions of soldiers returned home, the GI Bill was in full swing, and we saw the absolute explosion of the American suburbs. Places like Levittown just sprouting up overnight where there used to be empty fields.
And the entire physical and economic landscape of the country transformed. You had these massive industrial factories that had spent the previous several years churning out heavy military machinery and B-29 bombers. And almost overnight, they had to retool their assembly lines. They pivoted to manufacturing consumer goods, right?
Yeah.
Refrigerators, washing machines, microwaves, televisions.
And every single one of those newly built suburban homes needed to be wired for power.
Exactly.
Every single new washing machine and television needed a plug. You essentially had millions of households simultaneously creating a localized demand for electricity where, none had previously existed.
Right.
This created a massive multi-decade energy boom. Wealth shifted dramatically, creating an entirely new class of millionaires.
Yep.
But the people who made the real fortunes weren't necessarily the ones inventing the best toaster. They were the people pouring the concrete, laying the copper transmission wire, and building the regional utility companies.
That's the key takeaway. History doesn't perfectly repeat itself, but the economic mechanisms certainly rhyme.
I love that phrase.
Yeah, the foundational companies during that post-war boom, the utility providers, the grid operators, the equipment manufacturers, they won exponentially.
Right.
And the underlying logic of their success is crucial for us to grasp today. It simply didn't matter if you bought a General Electric refrigerator or a Westinghouse refrigerator.
Sure.
Regardless of which specific consumer appliance brand won the market share war, they all needed plugging in. The underlying infrastructure powered all the competitors equally.
Okay, I see the parallel, but I have to push back here for a second.
For it.
But wasn't that a consumer-driven boom? This time, it's corporations driving the demand. How does that change the dynamic? I mean, back then it was millions of individual middle-class families buying individual appliances over a span of 20 years.
Right.
But today, It is a handful of the wealthiest mega cap tech companies on Earth driving the demand.
Yes, and that distinction changes everything about the velocity of the capital.
Okay, how so?
A consumer-driven boom is gradual. It takes time for millions of households to save a down payment, secure a mortgage, buy a house, and furnish it. But a corporate-driven boom, especially one funded by hyperscalers, who literally hold hundreds of billions of dollars in cash reserves, is hyper-concentrated and brutally fast.
Wow. Yeah.
Silicon Valley is in an existential arms race.
Mhm.
If they wait 10 to 15 years for local municipalities and public utilities to slowly upgrade the public power grid through taxpayer bonds, they lose.
Right, because in the AI space, if your model stops learning because you ran out of power, your competitor's model overtakes you,
Exactly.
and your trillion-dollar valuation just evaporates. So, because the public grid is too old and too bureaucratic to adapt, these tech giants are essentially taking matters into their own hands.
Yes.
They are pivoting from being purely software developers to becoming heavy-duty energy companies.
Exactly. The timeline required by AI simply cannot wait for the traditional utility model to catch up. And, this brings us to a monumental shift in strategy.
Okay.
In March 2026, major tech CEOs met directly with the Trump administration to discuss a radical solution.
Wait, to discuss what?
Getting Silicon Valley directly involved in the energy business by building their own nuclear power plants.
Wait a minute. You're telling me that the companies responsible for social media feeds, smartphones, and search engines are going to suddenly build and operate nuclear reactors?
Yes.
That is an incredibly complex, highly regulated industry. You don't just write a software patch for weapons grade or, reactor grade uranium.
No, you definitely don't.
Navigating the Nuclear Regulatory Commission usually takes a decade of red tape alone.
You're absolutely right to be skeptical, which is exactly why those meetings took place at the highest federal level.
Mm.
The tech sector knows they cannot navigate the traditional decade-long red tape.
Right.
Following those discussions, the Trump administration signed an executive order specifically designed to dramatically accelerate nuclear permitting and development in the U.S.
Okay.
If we look purely at the economic and infrastructural implications of that order, it changes the entire timeline and cost-benefit analysis for these tech companies.
Wow. And we should probably clarify why nuclear is the only viable option for them. I mean, if you're a tech company with endless cash, why not just build a massive solar farm or a wind turbine field right next to your data center?
Well, because of the specific nature of how data centers operate, they
Yeah.
run 24 hours a day, 7 days a week, 365 days a year.
They never turn off.
Right. They demand what the energy sector calls baseload power,
Mhm.
constant, massive, uninterrupted electricity.
Oh, I see.
You cannot rely on intermittent sources like wind or solar because the wind stops blowing and the sun sets. And battery storage at that scale just isn't viable yet.
Makes sense.
Nuclear power provides incredibly dense, carbon-free, always-on electricity. It is the exact perfect puzzle piece required to run an AI data center safely.
The CEO of NVIDIA laid out a framework recently that perfectly summarizes this entire
Oh,
ecosystem.
yeah, the cake analogy.
Exactly. He described the AI revolution as a 5-layer cake. At the very bottom, forming the foundational layer, is energy. Above that are the microchips, then the infrastructure, then the AI models themselves, and finally the actual software applications sitting on top.
Yep.
But he also pointed out a staggering geopolitical reality. Right now, while the US economy is vastly larger overall, China currently possesses twice as much energy capacity as the United States.
Which represents a critical bottleneck for the American tech sector.
Yeah.
If energy is the physical base layer of that cake, you simply cannot build a taller cake than your base layer allows.
Right.
It doesn't matter how smart your software engineers are if you can't turn the servers on.
So true.
This is exactly why the NVIDIA CEO is now publicly predicting that major tech companies will be running their own proprietary nuclear reactors within the next 6 to 7 years.
That is just wild to think about. Imagine you were in this situation. What decision would you make? Write your thoughts in the comments.
Yeah, it's a tough call.
I mean, if you were the CEO of a multi-trillion-dollar AI company, would you wait for public utility companies to spend a decade updating the legacy grid, risking your market dominance? Or would you just hire a team of nuclear physicists, leverage your cash reserves, and build your own private power plant?
When you look at the sheer amount of capital at stake and the existential threat of falling behind in the AI race, the decision almost makes itself, right? They have to build.
They really do. So, what does this all mean? With all this money moving so rapidly into new physical infrastructure, How are people actually getting exposure to this?
Good question.
Like, if the market is shifting from software back to hardware and raw energy, where is the capital actually flowing?
Well, the market is currently approaching this through specific investment vehicles, often utilizing ETS to capture broad trends without picking single stocks.
Right, broad exposure.
Yeah, if you are looking at broad exposure, capital is flowing into vehicles like the XLE, which covers the wide swath of U.S. energy.
Hmm.
Your traditional oil, gas, pipeline, and legacy utility companies.
Yeah.
It's a macro bet that energy demand across the board will rise. Then you have vehicles like the XLU, which focuses strictly on the utility companies that are currently tasked with attempting to rebuild these public systems.
But if you want to follow the tech company's specific pivot to nuclear and grid modernization, you can look at the niche exposure rate.
Exactly.
You have vehicles like NLR, which covers the nuclear industry specifically, including the specialized utilities operating existing nuclear plants.
Yes.
Then you have URA, which focuses on global uranium miners. Because here is the critical mechanical reality about nuclear energy uranium is the raw fuel. And from what I understand, the supply chain for uranium is incredibly inelastic. You can't just flip a switch and get more of it tomorrow.
You certainly cannot. The mechanism of uranium supply is a massive bottleneck. I mean, you have
Yeah.
to locate the deposits through geological surveying, navigate years of environmental permitting to even open a mine, extract the raw ore, mill it into yellowcake, and then run it through highly specialized enrichment centrifuges before it can ever become a fuel rod. Right. That entire supply chain takes 5 to 10 years to expand.
Wow.
If dozens of new nuclear plants are suddenly fast-tracked by the government and funded by tech giants, the demand for the raw fuel will violently outpace the current supply chains.
That makes a lot of sense.
And finally, there are vehicles like GRID, which focus purely on the physical hardware. We are talking about the industrial manufacturers pouring the concrete, winding the copper for the massive transformers, and, building the heavy transmission lines.
It's the oldest cliche in finance, but it's playing out perfectly right now. The classic picks and shovels analogy from the 1849 gold rush.
Absolutely.
During the gold rush, a few individual miners struck it rich, sure, but most of them went broke digging in the dirt. The people who consistently built generational wealth were the merchants selling the picks, the shovels, and the tents to the miners. Right now, we don't have to guess whether Google, Microsoft, or some stealth startup in a garage will win the ultimate AI software war. If you are looking at the shovels, the industrial transformers, the uranium enrichment facilities, the heavy grid hardware, you realize that whoever wins the AI war will be forced to buy those materials.
That is a highly strategic way to view the landscape. But it is crucial that we emphasize critical thinking here.
Yes, definitely.
This discussion is an educational breakdown of macroeconomic trends,
Mhm.
not financial advice.
Right.
We're looking at the mechanics of the capital flows as they stand today. But in macroeconomics, variables always change.
Always.
AI adoption could hit a plateau. Government policies regarding nuclear energy could pivot dramatically based on public sentiment or safety concerns. Investments in heavy infrastructure are illiquid, long-term, and they always carry the risk of loss.
For sure.
The goal here is to understand the mechanisms of the shift, how a digital query translates to a burning fuel rod, so you can evaluate the landscape clearly.
Absolutely. We are here to decode the map, not tell you where to drive. And hey, if you're interested in financial education, investing, and understanding how money works, make sure to subscribe to the channel. We regularly break down complex financial ideas in simple terms.
Because understanding these underlying mechanisms is really how you navigate an economy that is fundamentally restructuring itself from the ground up.
And, when we talk about restructuring from the ground up, we have to recognize that rebuilding the US energy grid requires millions of tons of raw materials.
Yeah.
Because we need massive amounts of steel, specialized copper, and heavy industrial components, a huge percentage of which are manufactured overseas and imported into the US.
Right.
Which brings us to a massive macroeconomic hurdle regarding how we actually pay for this infrastructure boom.
This raises an important question about the broader federal economic environment in which these tech and energy shifts are occurring.
Okay, lay it out for us.
The very way the government funds itself might be undergoing a radical shift. Recently, President Trump confirmed a desire to get rid of the modern-day system of income tax entirely.
Right. The proposed plan is to substantially replace the federal income tax system with a comprehensive system of tariffs.
Yes.
So these would be taxes paid by foreign countries on the goods they import into the United States. The stated goal is to remove the direct financial tax burden off the shoulders of everyday American citizens.
And, regardless of one's political views on the matter, we really have to impartially analyze the sheer scale of the macroeconomic changes on the table.
Definitely.
If you impose heavy tariffs on imported goods, it directly impacts the cost of importing the steel and copper required to rebuild the energy grid. It changes the cost analysis for every single piece of infrastructure we've discussed today.
Whether this tax overhaul happens entirely, partially, or not at all, it perfectly illustrates the magnitude of the current moment.
It really does.
We are talking about rewiring the physical energy grid, fast tracking the privatization of nuclear power, and potentially rewiring the entire federal tax code all at the exact same time. It is an era of heavy, physical, structural change.
When you zoom out and look at all these puzzle pieces together, a very clear picture emerges. We are rapidly moving out of the era where the world's greatest value was created purely by writing clever software code in a dorm room.
Right.
We're entering an era dominated by heavy industry, massive capital expenditure, and physical infrastructure.
Let's bring this all together. The core takeaway from everything we've looked at today is that the AI revolution is, in reality, a secret energy revolution.
Perfectly said.
The seemingly frictionless digital magic of artificial intelligence is brutally forcing the modernization of the outdated US power grid. It is pushing the wealthiest tech giants in the world to become heavy duty energy companies, driving them toward nuclear power just to keep their data warehouses from going dark. And all of this is creating massive generational shifts in how capital is being deployed across the global economy. We are finally trading digital ghosts for heavy physical realities.
And that physical reality brings up one final provocative thought to leave you with.
Oh, I like these. What is it?
If these tech giants, with their endless capital and relentless drive, successfully navigate the red tape, build and manage their own private nuclear reactors, what happens when they inevitably generate more power than their data centers actually need?
Oh, wow.
Will they eventually start selling that massive surplus of power back to the public grid? We might be watching the birth of a reality where tech companies become the ultimate, inescapable utility monopolies of the 21st century.
Thank you for watching this video all the way to the end.
If you enjoy this discussion, subscribe to the channel, leave a like, and we'll see you in the next breakdown.